Hello everyone, this is Mr. Fugay, and for our video here today, we're going to talk about the distance formula. So prior to this, you probably have talked about the midpoint formula. So just a quick difference between the two so you know that we have different objectives here. The midpoint formula is trying to locate a position, a place that is going to cut a segment into two equal parts. So you're finding a point. This is not what distance is. Distance is trying to find a length. So we're looking for a numerical value of how long a particular segment is. So that's what we're going to talk about in this video. But before we do that, we're going to talk about something you may have learned in the past, and that is the Pythagorean theorem. So a quick review here is when you're working with a right triangle specifically, if you know two of the lengths, you can use the formula a squared plus b squared equals c squared to find that missing length. C squared, of course, is going to always be called what's called our hypotenuse. Hypotenuse, got to spell that properly. And that's always going to be the side that is opposite from the 90-degree angle. So just a quick review of that. I have three quick Pythagorean theorem problems for us to try. And in all of these, I want you to try to write your answer in radical form if possible. If you think you can do this, go ahead and press pause and try it yourself, and then I'm about to walk through them first. And we're going to start with the one in purple, if you want to walk along or if you're checking. So my c squared in this situation is going to be this side because here's my 90-degree angle. So my a and my b are 4 and 2. It doesn't matter which one you put first. So let's go ahead and put 4 squared plus 2 squared equals c squared. 4 squared is 16, 2 squared is 4, and then 16 plus 4 is 20. The last thing we need to do to solve this is take the square root of both sides, and so that my final answer here ends up being the square root of 20. Now, as a decimal, the square root of 20 is approximately equal to 4.4. So C is approximately equal to actually 4.47, so we'll round to 4.5. If you want to break this down as a radical, we know 20 can be broken down as 4 times 5. 4 is the perfect square, 2. So the exact answer here would be 2 root 5. So that's going to be our lengths for the first problem. For the second one, very similarly, I have given you the a and the b value, and it's the c value that we're looking for. And so for this particular problem, it would be 6 squared plus 1 squared equals c squared. This will be 36 plus 1 equals c squared. 37 is what 36 plus 1 is. Take the square root of both sides, and we get the square root of 37 equal to c. Now, if we're going with decimal approximations for this, the square root of 37 is approximately equal to 6.1. 37 does not go into anything. It is considered a prime number. And so this radical will not break down. And so the simple radical answer for this one would be the square root of 37. One more Pythagorean theorem for us to check out, and that's the one here in orange. So if we look at this one, once again, we are trying to find the c value here. So we're going to do 6 squared plus 6 squared equals c squared. 36, 36, that's 72. Take the square root of both sides. And so our unsimplified answer is square root of 72. If we're going with decimals for this, the answer is approximately 8.5. If we break it down, 72 is 36 times 2. 36 is a perfect squared. So that means that the simple radical answer would be 6 root 2. Okay, so that was Pythagorean theorem, and there's a reason that we just spent the first 4 minutes doing this. So I'm going to be able to address that in a couple moments. But let's shift gears for a second, because I'm now going to introduce to you the distance formula, which may not seem like it's related, but just stay tuned. The distance formula says that if you were given the end points, which are x1, y1, that's your first point, and x2, y2, your second point, that you can then find the length using the formula that I have listed below. So for the first example we're going to do, I want to use the points 3, 7 and 7, 4. So to do that, we're going to identify, well, 3 is x1, 7 is y1, 7 is x2 down here, and 4 is y2. So to set up our formula, it would be the square root of So x2 is 7, so it'd be 7 minus 3, quantity squared, plus 4 minus 7, so I'm just picking those from there, and then we can simplify. Now, you can use a calculator at this point of the game. If you want to throw it all in one step in the calculator, that's fine, but for this video, I also want to show you how to do it by hand. 7 minus 3 is going to be 4. 4 minus 7 is negative 3. That needs to stay in parentheses so that we don't lose that negative sign. 4 squared is 16. Negative 3 squared is 9. 16 plus 9 is 25. And yes, the square root of 25 is 5. So what we can conclude from this first example is that the length, the total distance between those 2 points, has a length of 5. So we're going to try the distance formula with 3 different examples below. And that's what example 2 is going to have us do. So let's go ahead and use the distance formula. I'm going to do the first one, and then I'm going to have you try the second 2 on your own. So I'm going to first identify the first point 1, 2 as x1, y1, and this as x2, y2. So using that distance formula, which is right there, we're going to set it up as the square root of, and in the first parenthesis will be x2 minus x1, so 5 minus 1 squared. The second one will be y2, which is 4, minus y1, which is 2 here. Let's go ahead again. You can plug this in your calculator if you want, but for the purposes of this video, I want to walk through how to actually do it. So 5 minus 1 is 4, 4 minus 2 is 2. 4 squared is 16, 2 squared is 4. Take those and add them together, you get 20. And again, if we want to leave this in simple radical form, we could do one of 2 things. So the square root of 20 is approximately equal to 4.47. That's the approximate answer, or the exact answer. So why don't we say distance equals? Let's go with that. Distance is approximately equal to 4.5. And then we saw that one earlier, I think, right? Because it was 4 and 5, 2 and 2. So I think the distance, the exact answer for this first one is 2 root 5. Okay. So I want you to try the red example and the orange example for me now, and the distance formula. And as a challenge, try to do it by hand. Try to do it the way that I did it, where you show all the steps, and then I will have answers for us to look at here in about 5 seconds. Welcome back. So if we look at the second 2 examples, the only thing I want to make note of is to be very careful with the negative signs. The formula does have a minus sign in it, so that's the formula, and then the number was -4. So in this one here, it was 2 minus -4, which is really the same thing as plus. So 2 plus 4 is 6. And then in this one, like -1 minus -2 is really -1 plus 2, so that's why I got 1. So for the red example, I got the square root of 37. That one does not break down. It's a prime number, and it approximately is equal to 6.1. And then for our orange example, once again, we just got to be careful with those negative signs. So minus a negative really is plus. That's why we got 6. Make sure that when you square a negative number in your calculator, if you're going to use that, make sure you put it in parentheses. Otherwise, it will not square it properly. So for the orange example, I got square root of 72. It's approximately 8.5, and it is equal to, as simple radical form, 6 root 2. Now, if you're feeling a little deja vu, that is on purpose. And the reason why is I want to go back to our Pythagorean theorem problems. Take a look at the processes we did here. In fact, I'm going to take a quick moment and do a very quick screenshot here because I want to establish what's going on here. So let's take a screenshot. I'm going to take those answers and I'm going to copy them down below because I want to directly compare those to the distance formula problems we just did. So take a look here, okay? So let me move this over here so you can take a look. The process for the Pythagorean theorem is almost the exact same thing as the distance formula. Take a look at the numbers. The process here was you square them, you add them, you square root them. You square them, you add them, you square root them. What the distance formula actually is a formalized version, I don't know if that's a word, but it is a Pythagorean theorem put into a formula. So if you're not one that you like to work with formulas and you rather look at things from a visual perspective, take a look really quick at this. This is the most powerful part of this lesson. If you instead looked at the picture and you say, you know what I'm going to do? I'm going to draw a line up and I'm going to draw a line over. And when I do that, I'm going to count 1, 2, 3, 4. And then across 1, 2, 3, 4, 5, 6, 7, 8. Interesting. So when you get that, okay, well, I think I might have counted by halves, actually. I just realized those are halves. So this is actually a 2. This is a 4. My apologies. This is 2, 3, 4. So 2 and 4 are my legs. 2 and 4 are the numbers in the distance formula. If I use this triangle, right, I'm going to go up 1, and then I'm going to go over a total of 6 here. Oh, look, 1 and 6. And then in the last one, if I count up and over, I can make right triangles by using the rise and the run. So in this case, this is up 6, this is over 6. That ends up being as well 6 and 6. That's exactly the first 3 problems we did with the Pythagorean theorem, is that I had given you the rise and the run of that particular segment, and we set up a Pythagorean theorem. So back up here at the very, very beginning, the distance formula is nothing more than the Pythagorean theorem. So if you're one that you like to do things in a more visual approach, by all means, I will allow you to use the Pythagorean theorem. These are the same thing. So we're going to end the video with 3 more distances that we're going to practice. So here is the last piece. If I have a shape like a triangle, and I want you to find the perimeter is the total length of all 3 sides of that shape. I want you to use the distance formula in this example to find all 3 lengths. And we can find those in decimal form. So let's get those in decimals in this situation. And we'll call this point A, we'll call this point B, we'll call this point C. So what I want you to do is to find the length of the green segment AB. I want you to find the length of the red segment BC. And finally, I want you to find the length of the segment AC. Once we find all 3 of these lengths, based on the definition of perimeter, we can find the perimeter of this triangle simply by adding them together. So I'm going to have the setups on here and the answers, and we will go over it in just a moment. Go ahead now and take the next few moments to pause this video and try these 3 distance formulas out. Here are my 3 distances. So I found the length of the green segment AB. Remember that if your formula, the formula is written x2 minus x1 squared plus y2 minus y1. What do you count as your first x versus your first y? Does not matter as long as you stay consistent. So for example, I'm not going to do this for all 3, but I had made this my 2 and I had made A my 1 for the green segment as an example. I put this in my calculator to get a decimal answer this time, so we got 8.5. For segment BC, I had C as my second point and B as my first point, and then I set that up in my formula, got 11.2. And for AC, I believe I had my C as my second point and A as my first point, and I got 10. So in order to figure out the perimeter, the last part of this is the total length of all sides. So all we have to do to find the perimeter of this triangle is we are going to add up the 8.5, the 11.2, and the 10. And so the total distance or total length of this triangle is 29.7. And that is where we will put a bow on the distance formula, okay? So just remember, it is really just the Pythagorean theorem at the end of the day. Thank you guys for watching this video. I hope you found the information helpful, and good luck in your practicing of this idea.